So in this video, I'm going to review exact equations and give a general recipe of how we actually solve them. So as we saw in class, a differential equation, which is of this form, right? It's a first order equation. Any first order equation can be written in the form 1. And we know that it's exact if we can find a function psi that depends on x and y, so that if I differentiate this function with respect to x, this equals m of xy. And if I differentiate with respect to y, this equals n of xy. Now the existence of such a function is nice because then I have that the equation 1 is equivalent to the x derivative of this function equal to 0, which I can then solve this equation easily because all I have to do is undo the derivative. I integrate, and I get with psi of xy is equal to a constant is a solution to 1, right? It's an implicit solution, but nevertheless it's a solution. Obviously the big question is how to find this function. And the first step actually is to determine whether an equation is exact. And the theorem that we saw in class basically tells us that, provided, m and the partial of m with respect to y and the partial of n with respect to x is continuous in some rectangle, let's say, then my ODE here is exact in that rectangle if and only if m sub y is equal to n of x, okay? And it's going to be exact for all x and y in that rectangle. So the power of this theorem is in letting us know whether an equation is exact, right? So here's an example, and if I want to determine whether it's exact, I know that this guy is m of xy, this guy is n of xy, and so all I have to do is take the partial of m with respect to y, which is just 2x, and the partial of n with respect to x, which is going to be 2x. Okay. So given that n sub x is equal to m sub y by theorem 1, let me call this 3. 3 is exact. Okay? So that means that there is hope to find the function psi of x, y that will give us a solution. Okay, how do I find the function psi such that it'll solve my differential equation here? Well, remember, I want this to be the derivative with respect to x, and I want this to be the derivative with respect to y. Okay? Okay, so the first thing that we're going to do is we're going to set the partial of psi with respect to x equal to my function m, and I'm going to integrate with respect to x holding y constant, right? And so then you end up with psi of xy is some function q of xy plus then a function that only depends on y. So for example, this could be the integral from x0 to x of m of s y ds. Okay, the next step is to differentiate now the function psi with respect to y, okay, and we're going to set that equal to n of xy, right, because that's what we want from here. So we have that q sub y, right, the partial of q with respect to y plus h prime of y is equal to n sub y. Okay, the last step is to solve for h. So we know that h prime satisfies n sub y minus the partial of q with respect to y, which is a function of x minus y. Now, in order to solve it, this guy, right, the right-hand side better be a function of y only, right? So we have that this has to be true, right? This has to be only a function of y. And you can check that this holds if and only if n sub x is equal to m sub y, right? The partial of n with respect to x, the partial of m with respect to y, which is where that condition comes from, okay? But now we really have our solution, right? Because I can find q, right, just by finding the antiderivative of this guy. And now I know how to solve for h by solving this guy right here. So let's now try an example. So the first thing that I want to do is check to see if it's exact. So this is m and this is n. So is it exact? Well, let me look at the partial of m with respect to y. I get 2x. And now the partial of n with respect to x, I get 2x, right? Since my is equal to nx, I'm in business. So now I can try to solve it. So remember my steps, right? So step 1 was to set the partial of x, or the partial of psi with respect to x equal to m, which in this case is 2xy. I'm going to integrate, and I end up with psi of xy. The antiderivative of this guy is going to be, so it's with respect to x is going to be x squared y plus a function of y, okay? The second step is to now take the derivative of c with respect to y, so we end up with psi y is equal to x squared plus h prime of y, okay? And we want this to equal n of xy, which in our case is x squared minus 1. Okay. So now we have that we can actually solve for h prime, right? So the next step is to solve for h prime, and this tells us that h prime of y has to be, well, x squared minus 1 minus x squared. So it's just going to be minus 1, right? And so I can easily do this. I know that h of y has to be y, okay, plus some constant, okay? Okay, so now I know what my solution is. I know that psi of xy is going to be x squared y plus y plus a constant, right? So I can write it as psi of xy is equal to 0 in this case. The other way I wrote it in class is I can choose to write it as x squared y plus y. So let me call this sort of a different function. And then the solution would be psi of xy is equal to c. So it's really the same, but I'm choosing to write it in two different ways. And in a sense, I'm just moving c to the right-hand side. So this is how we solve exact equations. And in class, we're going to spend a little bit more time discussing this, how to make some non-exact equations exact, and then we will move on.